Hello. Hi, everyone. Welcome to my talk about multi-tenancy. First of all, enjoy your break. I know it's a coffee break. I hope you still have some energy to follow the presentation. So let's start. First of all, a little bit about me. I work for a company called Loft Labs. You can think of us as the guys that like Kubernetes so much that we put Kubernetes in Kubernetes. So our main product is called Virtual Cluster, and it's a fully virtualized Kubernetes. I worked as a head of engineering enablement, which is a fancy title for platform engineering. You can snap this. I'm not sure if it's probably too small, but this gives you my LinkedIn profile. And let's start by talking about what are platforms. Our talk about will be multi-tenancy in developer platforms. So why do we even need platforms? Maybe if I can get a show of hands, if you're working with multiple teams and providing platform services. All right, a few people, cool. So hopefully this will be interesting for you. So just to set the level, platforms essentially are a way for us, platform engineers, to provide services to developers to make their life easier, hopefully, not harder. And platforms achieve several objectives. Here I just selected a few to talk about it. So simplified resource management. Platforms enable us to manage all the resources, whether it's cloud or Kubernetes in our case, in the same way. They hopefully increase development efficiency, although they might decrease it at the beginning when we're experimenting with it. But at the end, they should increase development efficiency and reduce friction. And finally, developers usually do not think about scalability on other entities. So we platform engineers are typically tasked with doing just that. And platforms are built from the ground up with this in mind. So how do we build developer platforms? Within the cloud native space, there are a few criteria that you can apply to see if your platform is actually built in the most efficient way. So first of all, API driven. This is something that is especially interesting in Kubernetes space. If you have a contract with developers that is enforceable with API, that's the right thing to do. We are following cloud native principles, and nowadays almost everything has a GitOps workflow applied to it. So this is just a reminder of what the platforms are and why they are important. Now, once we have the platform, hopefully a lot of teams use it, and we have a challenge of multi-tenancy. And if you think of multi-tenancy, there's a few ways to slice it. So I like to think about multi-tenancy in these three categories. So first of all is isolation spectrum. You might have no isolation whatsoever, so your platform might serve developers all equally, there's no isolation. You might have logical or software isolation. So those are things like namespaces, vCluster, and other ways. Or you can have physical isolation, which is give them, in our case, talking about Kubernetes, brand new EKS cluster. We have resources sharing. So this is quite interesting and difficult to do because some teams might need Nginx ingress controller, some teams might need Istio, some of them don't. We might need to configure it differently for different teams, so it can become unwieldy pretty quickly. And finally, multi-tenancy requires different trust levels. So if the service is not critical, we might have an open trust, so we expose it to anybody, up to a zero trust, where only authenticated team members can use it. What is really interesting that in practice, all those multi-tenancy approaches can be mixed and matched, or should be mixed and matched. So you might start with one, and you might transition to the other. Or you might have one team that requires a very strong isolation boundaries, but maybe they can a little bit of open trust level, and so on. And you have, in reality, those things often overlap, and they are quite complicated to express using the current tools. So how does it work in terms of Kubernetes? If you think about Kubernetes, there are two main modes of isolating workloads. One is namespaces, and I apologize for the cutoff here with the diagram, but I hope it's still visible. So namespaces, as we all know, it's a very weak isolation mechanism. Weak because you cannot really enforce it that well, and developers or whoever uses it don't have access to global Kubernetes resources like CRDs, which in some cases might be needed. And from there, you can move all the way to separate clusters. So think of creating a separate EKS cluster for your QA team or for other teams. And that's, of course, it's difficult to maintain and pretty costly. So how it looks with vCluster, specifically from the workload isolation. And can I get a show of hands who already worked with vCluster in any capacity? Ah, cool, few people, all right. So for those of you who haven't, what vCluster is, it is essentially Kubernetes control plane, fully fledged Kubernetes, encapsulated in a container in a pod. So why would we do this? Well, isolation is one of the use cases. So think of virtual cluster as a pod running on your host cluster, and you can connect to it through API server, and it can have its own rules of how it manages and deploys workloads. Because it is a fully fledged Kubernetes distribution, you can do things like have one vCluster with 31 version, one vCluster with 33. You can have vClusters with different resources allocations, and so on and so forth. And there's quite sophisticated configuration mechanism that vCluster supports. So if you think of workload isolation using vCluster, this is kind of how it looks like. You have one single host cluster. This can be bare metal. It can be managed Kubernetes like EKS or GKE or whatever else you have. When you will see this in a moment, it can be also kind cluster. And inside of this, you have pods running those Kubernetes clusters in a virtual way. The name should really be containerized Kubernetes cluster, because that's what it really is. And then those pods, those workloads, are accessible from within the vCluster, only those specific pods. We'll see this in a second in a short demo, but that's kind of the gist. So now you can start deciding which team needs a full isolation, which team needs just a little bit, how you group your workloads, and so on and so forth. So now we're going to swap to super quick demo, and this demo is a little shorter than usual because we have just 20 minutes, but if you would like to ask any questions after the demo or dive deeper, visit us on the booth at the stairs on the ground floor. I'll be happy to dive deeper in the demo. So let's see, first of all, what do we have? So you can see here, I hope you can all see it. Is it big enough? Right? So this is my local kind cluster. It has a lot of stuff. So this is your typical cluster that runs certain workloads, and in our case, what we are running here is crossplane resources. Anyone familiar with crossplane? Yeah, cool. So I encapsulated crossplane inside of virtual cluster and deployed some things to the cloud. So what those things are, let's go back here. So again, I'm gonna skip through this real quick because we don't have time. But at the end, this is this super important app. This is gonna sell, right? It supports emojis. This is really cool. So this is our app. Alongside the app, we have deployed a bunch of Azure resources. Apologies for the black theme here. But this is just to show that this is not a trivial demo. There's quite a lot of things involved in it, and all of this comes from within the Kubernetes cluster we've just seen. Again, talk to me if you're interested in any of those components and kind of digging deeper how those things come together. So coming back to our K9S, you will see that we have here a kind demo local. Imagine this is your EKS cluster. So now I'm gonna swap and show you other clusters. I'm not sure why can't I swap through it, but there are other virtual clusters running here. You can see those two guys. So we have one cluster that is called DevOps team and one cluster team 2. I couldn't come up with the original name. So what is happening behind the scenes here is that those clusters are our ways to create a multi-tenant environment and multi-tenant experience for our teams. So how are we doing it? So here you can see an example of a configuration file for my virtual cluster. When I create a virtual cluster, remember, it's just a pod running in Kubernetes, special pod with Kubernetes management plane. You can see here that I am synchronizing a secret from host, which is from my kind cluster, up to my virtual cluster. In other words, every virtual cluster I'm going to create based off of this recipe, off of this config, is going to have this cross-plane secret. For those of you who use cross-plane, this is a way how cross-plane communicates to cloud providers and how it establishes connection. So in this case, if you remember the slide with various levels of multi-tenancy, this is like an open trust. I am sharing a secret on purpose. Maybe it's a dev environment, and I don't mind sharing it across various teams that will inhabit my various virtual clusters. You can see here also the ingress classes are also synced from host. So this is a very good example of a shared service. Most of us, for platform engineers, we typically have Nginx controllers, Istio, Cert Manager, other services that we don't want to install in every single virtual cluster. We want to be able to share either CRDs of those services, of those operators, or share some of the Kubernetes resources. In here, I am doing exactly this. So this means that my virtual cluster, although it doesn't have Nginx ingress controller installed, it shares the underlying ingress controller configuration from the host cluster. And finally, I am synchronizing back to host all the ingresses. So I can actually access web app in this case in my virtual cluster. Okay, so this file here, there's a lot of stuff, but this is a just file recipe. Anybody knows just file? Yeah, just file is super cool. It's like a make file, but focused on creating recipes. So what's happening here is just a simple setup that tells me if I am creating a virtual cluster here, I am applying all kinds of YAML files. Those are mostly cross-plane files. And then I'm creating this for my team too. So notice what just happened here. I have my own setup, which is the demo that I just briefly showed, that contains all the cloud resources that I, as a platform team, want to expose to my teams. In our case, we are creating an Azure service account. This is like an S3 bucket, but cooler. So once I did this, I can start bringing team 2, team 3, and other teams in this kind of way of having flexible multi-tenancy. In my case, I opted to give cross-plane to all my virtual clusters, but share certain resources from the host cluster. So I hope that you can see with this how powerful the flexibility of vCluster is, because we will have teams and scenarios that are very different. Some team might need more or less, and with this ability to kind of slide the various sliders of multi-tenancy, we are able to express all those needs using virtual clusters. So now let's go back to the slides. And I want to summarize this real quick. So in this case, this is just a summary of the tools. And I want to, although I didn't show you the demo, I want to go through this because most of the platforms that we build are not trivial. And I really wanted to express this with the demo itself. So as you can see, there's quite a lot of tools. We have Kubernetes, we have vCluster, Crossplane, Port, GitHub, Argo CD, and others. And you will typically grow like this as a platform engineer, and your offering will not be trivial either. And vCluster can act here as this hub of helping you decide how and where you slice the isolation and tenancy for your teams. So how it looks like, this is a little bit, I hope it's visible. So this is just a journey of how typically developers start working with cloud-native platforms. So again, the demo was unfortunately super short because we don't have time, but I want to guide you at least through all the steps that typically would happen. So first of all, we have developer that uses some form of self-service. In my case, I'm using Port, but you probably are familiar with Backstage, but it's by any means a prerequisite. You can use YAML files or just GitHub repositories. At the end of the day, there's an entry point for developers that say, I want to provision something. When this happens, in most of the cases, we will have a GitOps flow, right? So in our case, we have a portal. I'm using Port. Port is connected to a Git repository. Pull request is being opened in the background. Once the pull request is opened, now we are in the Kubernetes land. And Kubernetes, in our case, is not just an orchestrator for containers, but is predominantly a control plane. So we are using Kubernetes in a much more broader way than we would normally think about Kubernetes in general, so just running my pods, right? In this case, Kubernetes here has vCluster that enables multi-tenancy. It has cross-plane that, in our case, provisions cloud resources. And it has the typical Kubernetes resource model and API that works behind the scenes, tirelessly reconciling the desired state and actual state. And we can take advantage of this fact and overlay those tools like vCluster and others to achieve this flexible multi-tenancy. So I am talking about multi-tenancy, but it's equally applicable to anything we want to develop as a platform in the cloud-native world. So what's happening specifically here is that everything I provision to a cluster is expressed as a Kubernetes resource, specifically either a CRD or a regular pod in terms of vCluster, and Kubernetes knows how to deal with those things. It applies them, provisions various things on the nodes, and we end up with a fully functioning platform. That's, of course, a shortcut. There's a lot of stuff happening in between. But at the end of the day, I find this recipe for building a platform to be quite reliable in various scenarios. Remember, we are focusing on vCluster and multi-tenancy, but this is much broader. So the recipe itself will work literally with anything that you apply here. At the end of the day, we as platform engineers here on the right side, we can be as much involved or as little involved as we want, depending on the multi-tenancy context. So what we have done building a platform, we have reduced friction almost to zero. Platforms that work that way, which enable developers to express desired state, reduce friction. The only friction was that we approved a PR that you didn't see, but again, if you're interested, I'll show you downstairs. We eliminated waiting times and created something that is easy to collaborate. Now, it's not easy to implement. This is complicated stuff. From our perspective, platform engineers, we are responsible for maintaining all the complexity, and we can, in turn, provide something to our internal or external users that is very simple. And I didn't mention AI even once, which is cool. So that's it. This is this QR code, which is this time big enough, so you can snapshot if you want. And this gives you a source code for the whole demo, so you can play around with it. You can connect to me with me on a cloudrumble.net, and that's all we have time for. Thank you, everyone.